Yo, wanna know what the EM spectrum is?
No, waiting, not again.
Okay, first things first. The EM spectrum is a continuous range of wavelengths.
Which means?
Well, it just means that it's very hard to place exactly where one wave stops and another continues. Okay, let me visually explain this. Radio waves have the longest wavelengths and the lowest frequencies and energies, right? The wavelengths get shorter as you approach gamma waves, therefore, the frequencies and energy increase.
Right.
Do you know what a wavelength is?
No. Okay, continue.
The EM spectrum goes radio waves, microwaves, infrared waves, visible light, ultraviolet, X-ray waves, and gamma waves.
How am I supposed to remember all this?
There's a mnemonic. Raw meat is very unsanitary except a giraffe.
You eat giraffe meat?
No, I don't.
Then why?
Okay, shush now. All types of electromagnetic waves are transverse waves, and they all travel at the same speed in a vacuum. So, in empty space, all electromagnetic waves travel at 3 times 10 to the 8 meters per second. And that's their speed, okay? Let's talk about radio waves. You know, the range of wavelengths for radio waves is usually 100 kilometers to 1 millimeter.
Ooh.
Which is around 300 gigahertz and 3 kilohertz. Yeah, but the typical size is 30 centimeters to 500 meters. Radio waves can travel long distances before just being absorbed by stuff, items, things such as buildings or trees because of their long wavelengths.
Radio waves have the longest wavelength.
Correct. They can also reflect off the ionosphere, which is a layer of charged particles in the air.
Right.
Okay, there are various sources for radio waves.
Is one of them radio waves?
Lightning or astronomical objects, such as 433 arrows, can produce radio waves. Artificial sources include cell phones, satellites, radar.
And broadcast tower. Radio waves are long.
Right. Okay, radio waves travel long distances, so they're used to transmit radio signals and radio waves from and to other radios. The very lowest frequency radio waves have the ability to reflect off the ionosphere, you know, the thing I mentioned earlier, allowing radio waves to be used in terrestrial TV.
Radio waves are long.
You've already used
So
it,
they're harmless.
well, large doses of radio waves are believed to cause cancer.
Okay, let's go to the next one.
Microwaves. Microwaves are the high frequency portion of the radio wave section of the EM spectrum.
Which is why it's a continuous range of wavelengths.
Yeah. The range for microwaves is 1 meter to 1 millimeter, and the frequencies are around 300 megahertz and 300 gigahertz. But the typical size for a microwave is around 15 centimeters, which is the length of your primary school
Our
rulers.
microwaves are longer.
Okay. Microwaves can penetrate the Earth's atmosphere without being reflected or refracted.
Reflection?
Try putting a straw in a glass of water.
Okay.
Hey,
What?
hey,
What?
hey,
What?
guess what microwaves are used for?
Microwaves?
Yeah. Artificial microwave sources also include circuits, transmission towers, radars, and lasers. And natural sources include the cosmic wave background and the sun, but most of it is blocked by the Earth's atmosphere.
Nice.
Do you want to know about how microwaves microwave? Water molecules absorb the energy of microwaves, which is both good and bad. Microwaves are used to heat up food, since most foods contain a lot of water molecules. However, microwaves may also cause internal heating of our body tissues because there are water molecules in our tissues.
We're going to do that information.
No, ask you, not me.
But, okay, let's move on to the next one.
Infrared waves. Infrared waves follow microwaves in the electromagnetic spectrum. Their range goes from around 1 millimeter to 0.74 micrometers, which is 300 gigahertz to 1 petahertz frequency-wise. Infrared waves transfer energy which is easily absorbed by the surface of objects, meaning it's normally referred to as those waves carrying heat energy.
Those waves carry
Okay, so
heat energy.
that's not their that's not their exact casual name, but I can't remember what they're referred to as. So
Switch it up.
I've tried. Okay, I've tried, but what could I put in exactly? Infrared radiation is felt as heat, hence the carrying energy thing, but that's not to mean radio waves or any other part of the spectrum don't emit heat or don't cause heat to be emitted.
Right.
If we go over to this electrical heater, because infrared radiation transfers energy which can be easily absorbed by surfaces of objects,
The infrared radiation from the heaters absorbed by objects in the room.
exactly, infrared radiation can also be used for some oven and optical fibers. Yeah, no, that's it for infrared radiation.
I'll give you the light.
This is right. This tiny portion of the electromagnetic spectrum is the only part of the spectrum that we humans can see.
Whoa.
Yeah, I know. The typical human eye can detect and respond to wavelengths of around 390 nanometers to 700 nanometers, which is around 400 to 790 terahertz if you really wanted to know.
Do you need to remember all those exact numbers for GCSEs?
As you know, a rainbow consists of 7 colors: red, orange, yellow, green, blue, indigo, and violet. As you also know, wavelengths decrease approaching gamma radiation. Therefore, the wavelengths of the colors in the rainbow increase as you go from violet to red. Red has the lowest frequencies and the longest wavelengths, whilst violet...
And that's relevant because
I just thought that was cool. We use visible light to our advantage through photography. With film cameras, the light is focused by the photosensitive lens, which is then developed to produce the wanted picture.
and digital cameras.
With digital cameras, or mobile phone cameras, light is focused by the lens into a little sensor containing thousands of pixels, and then all the information is stored in a memory card, where the image shall be produced. Very bright light can damage our retina badly, so you should never, ever look directly into the sun.
But that's just common sense.
Yeah, but come solar eclipses and then that all just goes out the window.
Yeah.
Ultraviolet!
Wow, I can barely see anything.
Ultraviolet radiation, beyond violet.
So for all coming waves, nothing can actually see these waves.
I mentioned earlier that humans can't respond to ultraviolet light, but I never said that other animals can't respond to UV. Birds, bees, and some fish can detect UV light. UV is typically around 400 nanometers to 100 nanometers in length, which is really small.
Really small.
Really small.
Really small.
The sun emits UV, which is bad.
Because
There's 3 main types of UV radiation, and they're classified as UVA, UVB, and UVC. UVC holds the most frequency, so it can cause severe damage to cells, including skin cancer.
most dangerous, UVC. Got it.
UVB has a lower frequency than UVC, so the effects are not as severe. However, UVB can cause severe sunburn and damage to cells.
UVB.
UVA has the smallest frequency and the longest wavelength, so it has weaker effects than UVB.
Longest wavelengths, UVA.
Shortwave UV, so around UVC, is ionizing, and the sun does, of course, emit all types of UV. However, we're protected from it by the ozone layer. Since UV waves carry more energy than visible light, they're more dangerous to human eyes. Therefore, UV waves can cause blindness. This UV poster absorbs all the UV light and emits visible light. UV is also used by sun tanning. Those, you know when they tan? Yeah.
Yeah, that's they tan.
Yeah, but not spray tan. The beds. Yeah, the beds.
But
Sun
it's
tanning.
dangerous because you can get hurt.
Yeah, it's dangerous, right? I just couldn't say it. That's why sun tanning beds. That's it. Ultraviolet waves can be used in light bulbs because they are more energy efficient than using visible light.
I see.
They're shorter wavelengths allows them to carry more energy than visible light. UV waves are created inside the bulb, and then the energy the waves carry, which is not being created, mind, is transferred to light energy.
So apart from the light bulbs, there's really no upside to UV.
I mean, if you're exposed to UVB, vitamin D gets produced in your skin, or that speeds up vitamin D production. I don't know. Right? Is it vitamin or vitamin?
I don't know.
What do you say?
Vitamin.
It's like the tomato thing. Because I said tomato. What do you say?
Tomato. You're just weird.
Alright. Okay, we're nearly done here. We just need to cover the really short wave area of the AM spectrum. The EM spectrum. X radiation and gamma radiation. X radiation. Unknown radiation. 10 to 0.01 nanometers. Ooh, very penetrative. Ooh, frequencies in the range of 30 petahertz to 30 exahertz. Boom! It originates from... Wait, did I talk about where UV originates from?
You talked about bulbs.
Right. X-rays are produced when electrons traveling at high speeds are stopped. Mutations happen all the time, randomly. However, X-rays increase the chance of one of the mutations leading to a fatal change in enzyme shape. Okay, we're veering into biology now.
Mutations.
Yeah, I'll tell you about those later.
No, waiting. Your explanations are
Okay, there's this
always
thing
really
called
long
a
and boring.
radiation dose, and it's the measure of the amount of damage done to the body by ionizing radiation, and it's measured in sieverts. The radiation dose. The radiation dose and decision to prevent someone from being exposed to any more radiation that is necessary depends on the type of radiation, as well as the length of the exposure and the energy absorbed by the body from the radiation per second. You already know. What are X-rays used for?
X-ray machines.
Correct. X-radiation can penetrate soft tissue, but it's absorbed by your bones. You know, they can also be used for medical treatment for some cancers. X-rays used for therapy carry much more energy than X-rays used for imaging.
Gamma radiation, the ruler of all radiations.
Correct. 10 picometers in size.
That's crazy.
Correct. Like X-radiation, gamma radiation is very penetrative. However, unlike X-radiation, gamma radiation comes from the decay of certain unstable nuclei such as K40, U235, and P244. You know the usual. Gamma radiation kills harmful bacteria, which is good.
Sure is.
Exposing food to gamma rays kills 99% of disease-carrying organisms, such as salmonella. Gamma rays can also be used to sterilize surgical equipment. Yet another use of gamma radiation is that it can be used to kill cancer cells in gamma therapy.
Cool.
Yeah. Cobalt-60 can be fired at a tumor from different directions.
We're following little meat is very unsanitary except the giraffe. I believe that we're done.
Yep. So, my little uneducated friend, what did you learn today about each part of the EM spectrum?
I've learned that all the different types of EM waves travel the same speed in a vacuum, and that the energy and frequency increases as the wavelengths increase in length. I've learned that the radio waves can travel long distances before being absorbed by objects, and microwaves can go through the Earth's atmosphere without
being reflected or refracted, yeah.
Yeah. I've learned that infrared radiation transfers energy which can be easily absorbed by surfaces of objects and can be used for optical fibers.
Correct.
I've learned that we use visible light to record stuff, and that shortwave UV can cause cancer. And I've learned that X radiation and gamma radiation are both very penetrative, but X radiation comes from stopping fast electrons, and gamma radiation comes from certain nuclear decay.
Well, I think my work is done. Yo, do you think this video is too long?
Probably. You talk too much about science.
Yeah, okay. Well, how do you think we should end it?
I don't know. Maybe one of us should ask the other how we should end the video, and then the video